Well, welcome to our first webinar in a series, A Watertight Approach. My name is Emily Ausma. I'm a Communication Manager at Sensilo, and I'm here with my colleague, Dr. Corine Carpentier, our water monitoring expert. Before we start, I would like to address a few organizational points. This webinar will be recorded. If you have not already done so, please mute your microphone and switch off your camera. Today we'll discuss the topic of the distribution network with our guest speaker, Matthew Stevenson of HAL24K Water. Additionally, we will have an interactive session. During the presentation, you can write your question in the chat box, and after Matthew's presentation, we will answer all those questions. If we do not manage to answer all the questions straight away, we will make sure you'll receive your answer to your question by email. After the webinar has finished, or if you're listening to the recording of this webinar, we are welcome to submit any additional questions or feedback. And please use the email address support@sensilo.com. Today we will focus our attention on the water distribution network, revealing the hidden problems in the distribution network using AI and data science. We will address the developments in both sensor technologies and advanced data analysis tool in order to facilitate process optimization. The distribution network has long been considered a black box, with treated water going in at one end and tap water coming out at the other. However, this black box can hide a number of problems, and the fact that the infrastructure is largely underground makes it difficult to detect these problems. Data science can help to predict or even prevent certain problems, ranging from water quality to quantity issues, thus creating a win-win situation for all parties involved. While AI and machine learning approaches are already being applied in a range of asset management scenarios, our speaker, Matthew Stevenson of HAL24K, moves away from the well-known examples and presents the latest thinking about how to deal with the hidden and sometimes uncomfortable problems that occur in the distribution network, which he believes could be solved with a well-designed data science approach. Our guest speaker, Matthew Stevenson, will present some examples of how to incorporate AI into utility asset management strategy in order to prioritize maintenance and optimize asset performance. Matthew is a lifelong lover of water and a seasoned technologist in the water sector. He has worked in and around the municipal water sector for more than 25 years, learning the ropes as an operational manager at Bristol Water in the UK, then transitioning to developing and commercializing water technologies and innovations for the global water sector for the past 12 years. As Europe Director at HAL24K Water, he has the exciting responsibility of managing the development of new artificial intelligence and machine learning applications for the water sector, a subject he's particularly passionate about. Welcome, Matthew. I think that's a brief introduction to you.
Thank you. Thank you very much.
Yeah.
So is it over to me now?
It's over to you. The screen is yours.
Okay, so tell me if you can see.
We can.
Cool. Okay, thanks for the introduction. That was very covered a lot of stuff there, so that's really good. Clearly, I'm going to be talking about AI and data science, and ultimately, specifically about the water network and where we as an organization see the applications, the potential applications being applied to help solve some of these longer standing issues that have been around and still are around in the water network. So I'm actually going to say I think the drinking water networks deserve a lot more attention than other parts of the water supply process, and I'll explain a little bit behind that. We have a lot of hidden problems. Let's talk, probably remind many of you about those problems. You probably know what they are, but it's always good to kind of rethink where problems are, because, as we see with the network, it's hidden. I'll talk a bit about the data science approach and how we see it being able to help. But this is a very dynamic situation, a very dynamic world when it comes to the application of data science. It's a relatively new in comparison to traditional engineering solutions. So it's quite an interesting place to be. I'll talk a little bit about the solutions that are out there, but really focus on some of the ideas for the future and how the data science approach could really be the answer to solving many of the problems that we've got with drinking water networks around the world. This is not particularly it's not focused on any particular place. Many of these problems are sort of global problems. Just 10 seconds about my organization, just so that you know why I'm here today and why I'm speaking to you about data science and AI. I'm not a data scientist myself, but as Emily's pointed out, my job is to interpret the way that data science and AI can help solve some problems in the water cycle, in the water sector. Because what we do as an organization, we do two things. We use data science to solve and find previously unseen connections within data. So that could be unique research, early stage research, to try and uncover relationships that have always been there but have never been uncovered. Little gems that may help move the industry forwards. So fairly innovative. And then often the second part of what we do is creating the output, the solution that's really practical use to operators, to asset managers, to those that are today functioning in the water sector. So we do a lot of software development. We create a lot of applications that incorporate the AI, the machine learning, the data science effectively that we work with. So that's just 10 seconds, maybe that's 20 seconds about us and why I'm here today talking about AI in water. So let's get back to water itself. And again, this may be, you probably know a lot of this, but I just love thinking back again to the challenge of supplying water through a pipe network. Wherever you are in the world, people are drinking 100 to 200 liters of water a day. If you had to deliver that, if Amazon had to deliver that for you in bottles, that would be a huge, not just quantity, but a huge weight. That's a big challenge to be delivering to every single household. And actually that's per person. So if you're a household of 4 like me, that's 600 kilograms of product being delivered every day. That's a challenge. But we're not doing that in vans or in vehicles. We're doing that through old pipes, typically old pipes. It's a worldwide challenge that pipe networks that have been, that grew up 100 years ago are now starting to show real age. And that's the challenge when we're carrying an ultra clean consumable. Pipes are pressurized. They have to be pressurized to push the water through. And that causes its own problem. If something goes wrong, it doesn't just lie malignantly there, it causes a problem. And of course, that is problems that exist underneath roads. So you've got the out of sight, out of mind challenge with buried infrastructure, but also very difficult access to pipe network in most places these days with the busy cities and streets that we live in. And then maybe the final thing to remind ourselves, because I don't expect this is anything new to anyone here, but it's always good to be reminded. We typically live in a world now where consumers are expecting more and more and more. What does that mean? That means that a poor quality of water is an absolute no. And thankfully that water quality around the world is better than it was, but it's not perfect. And consumers are not, they don't allow that. It's just not acceptable anymore. We also are, as people, we're much more focused on climate change and the impact of climate change and the impact that the water suppliers can have on the way that our drinking water is delivered, not wanting to lose that water, not wanting it to be expensive. These are the real kind of multiple challenges that face a modern water company today. So if the water network was was a static thing, then life would be a lot simpler, wouldn't it? We would design the pipes, we would pour the water in at one end, the pumps would run, and out it would come at the other end. The problem is it's not static, and things are always changing. And this is part of the reason why a data science approach has a real potential value to help solve some of the problems that come from the water network being dynamic. So what's dynamic about it? Well, we know that the challenges that we've got to deliver the right quantity, quality of water on a reliable basis every day, 24 hours a day, but at a kind of lower cost and lower carbon effectiveness. But we've got pipes that break, we've got changing demand depending on the seasons, depending on the time of day, which can lead to big problems in some parts of the world with undercapacity or overcapacity. Maybe even within one city, we have different parts of the network that are under or overcapacity. We've got changing water pressures within the network.